Let's talk about a plasma stove. This is coming from one of you asking a question. Hello, my name is Greg Friedman. On this channel, I chat about plasma and other science topics, but mostly plasma because that's what I do for a living. So let's take a look at the question. There has been some recent development in cooking top appliances that have replaced flame-based heating with plasma. So instead of having natural gas or propane burners, there are now plasma burners. I'm curious what your opinion is on this. Not just the practical uses, but also the efficiency of a plasma burner versus propane and natural gas. And is there anything that can be done to drastically increase the efficiency of plasma flames? The question then leads to wonder if the same plasma burner devices can be used to replace oxyacetylene torches for welding purposes, propane torches, and other high heat focused point uses. Well, it's an awesome question. Look, I'll start with a funny story. Back when I worked at Drexel University, one of the higher-ups was a big cigar smoker, and we're like, well, we'll make you a plasma cigar lighter. And we did. The thing was, gliding arc-based cigar lighter. And yeah, it lights cigars. It's an expensive, gimmicky thing when natural gas is cheaper than electricity and readily available everywhere. If natural gas is not available, what about resistive heating? That's going to light up your cigar and cook your chicken just fine. So why not plasma? At first when I read your question, I was like, nah, bullshit. But I dug into it a little bit, and I saw that some vendors are selling the so-called plasma stoves, even though most of it reads to me like marketing junk. And the pictures are, this is AliExpress, Alibaba, notoriously questionable Chinese vendors. Buy one. Check it out. I'd be curious. There are a couple of YouTube videos on plasma stoves, and I'm sure it would work. Absolutely. Look, you have a camping stove that you bring a little methane or natural gas canister or propane canister with you, light the flame, the canister runs out, you're out. Or you can bring an electric stove with a resistive or inductive heater and connect it to a battery, same problem. Battery runs out, just like the propane tank runs out. Which one's heavier? Probably battery is heavier than the propane tank per unit of energy. So I would imagine camping-wise, propane would win, but I didn't do my calculations there. I'm just guessing. Now, resistive heaters and inductive heaters, they've been around for a while, so they're very well optimized. How would plasma do in this situation? Because resistive and plasma both use electricity. I would imagine just this is a hunch, a well-educated guess, nothing more. I would imagine the energy efficiency of converting electricity into heat for plasma would be questionable. I would imagine it would be less than that of resistive heaters, which have been optimized over the decades and decades of us having electric stoves at home. So I don't think that's very practical from that point, from energy efficiency point. Of course, we can optimize it and make it just perfect. My question is a little bit different. Have you seen plasmas? For a stove, you need thermal plasma. Thermal plasma, first of all, it runs hot, hotter than flame. And the higher the temperature, the more NOx you're generating. NOx is nitrogen oxides, things you don't want to breathe because they react with water producing nitric acid, and you don't want nitric acid in your lungs because you're sitting next to that stove. Now, ordinary burners, they also produce NOx, but I would imagine much lower concentration because temperature of my gas stove is lower than that of a thermal plasma. My problem with the whole thing is not that. My problem is when you have thermal plasma, you have two electrodes. One or both of them are under high voltage and they have to be open metal. So first, if you accidentally, total accident, you happen to bring your finger close to that arc, nothing stops that arc from jumping to your finger instead of to the second electrode. And you just electrocuted yourself, especially if you're bare feet standing on the grass in your camping. You're gonna die. So safety is my number one concern in that situation. What happens when you grab the handle of your frying pan, the metal handle of the frying pan, the arc could jump to the pan and go into your finger, and again you did. So I don't know. As a novelty for your boss's boss's boss to light his cigar once, for everybody to laugh, have a couple of drinks, and go home celebrating a big win, yeah, that was fun. Make it a commercial product. There's so many safety requirements. There are plasma lighters. It's really tiny plasma designed to light your candle or light your cigarette. To make that thing bigger, big enough to boil soup? I don't think so. Look, I'm working on a white paper together with some researchers on plasma uses, industrial uses of plasma as a heat source. And there are a number of really cool applications for plasma as a heater, as a source of heat. One is, and specifically focus on manufacturing. There are other ideas outside of manufacturing. Feel free to ask me in the comments section. I'm happy to expand on that. But in manufacturing, we can use plasma as a localized heating source. So let's say you want to bend a sheet of metal. You don't have to heat up the whole sheet. You can just run plasma, gently heat up the area that you want to bend, and then bend it. You can sputter clean. You can use plasma as a cleaner to prepare the surface, to clean the surface. You know, in space, there's vacuum. It's really cool. You can weld by just bringing two pieces of metal together. You bring them together, they touch, and they will just fuse together. No heat, nothing required. There's a catch. They need to be perfectly flat, and they need to be perfectly clean. No oil, no hydrocarbons, no water, no oxygen compounds. So you can use plasma, and plasma with addition of hydrogen, for example, to clean and prep the surface for cold welding. Very cool application. You can use plasma, as I mentioned, as a chemical reduction agent. So if you have contamination with hydrocarbons or water, plasma will very readily help you remove that from the surface using heat and reactive species that are generated in plasma. You can also, not a necessarily heat-related application, but plasma, use it for surface activation, so anything will glue to that surface better. And the most interesting, I think, is, I call it near-surface metallurgy. So you can use plasma to very quickly heat up very thin layer of metal surface to alter the metallurgical properties, to alter the properties of that metal. And all of these applications that I mentioned are really important, or they're gaining importance rapidly these days because of space manufacturing. In space, electricity is fairly abundant. During the day, if you can see the sun, you can collect the energy from the sun. At night, when you can't see the sun, you can run a small nuclear reactor and generate electricity. So electricity is pretty abundant in space, and plasma needs little more than electricity. So you can use plasma for a lot of space manufacturing. You know, it's hard to bring natural gas to space. So on Earth, natural gas is very competitive with plasma as a heat source. But in space, plasma drastically gains competitive edge there because all it needs is electricity. You don't need to bring tanks of gas with you. So, in short, to summarize this, plasma for cooking your hot dogs on Earth? I don't think so. Nope. Plasma in space for cooking your hot dogs. Astronauts are very well trained. You can teach them what to do, what not to do. Don't touch that arc, it'll hurt you. That is possible. So very specialty applications, yes. And to answer the other part of the question, in a specialty application, you don't give a shit about the price. So yeah, no problem. Thanks for an awesome question. It was fun to answer and fun to tell the cigar story. I love remembering that one. And if you have any other equally awesome questions or any other questions, please post them down in the comment section. I would love to chat about them. Peace. I'll see you in the next video.